Hello everyone, today we're going to be working through a Maclaurin Olympiad, question 6 from 2010. The question states that every day for the next 11 days I shall eat exactly one sandwich for lunch, either a ham sandwich or a cheese sandwich. However, during that period I shall never eat a ham sandwich on 2 consecutive days. In how many ways can I plan my sandwiches for the next 11 days? So to start solving this question, first we need to think about trees. So on the first day, we have 2 choices. You can either eat a cheese sandwich or a ham sandwich. On the second day, if we picked ham on the day before, we can't pick ham again. So that's why we only have one choice here of cheese. If we pick cheese on the previous day, we have 2 choices of either another cheese or a ham. If you continue this down for all the days up until day 4, we get a nice tree here. Now we can try to spot some patterns. Think about the total plants on each day. So on day 1, there's 2 total plants. And on day 2, there are 3 total plants. On day 3, there are 5 total plants. And on day 4, there are 8 total plants. Now we need to try spotting a pattern in this total. And if you look carefully, this is just a Fibonacci sequence, because each total is the sum of the 2 totals of the 2 days before. For example, 5 is equal to 2 plus 3, and 8 is 3 plus 5. And if you carried on this tree forever, we'll find that this pattern continues. So now we just need to prove why that the total quantity of meals for any day is the sum of the previous 2 terms. And to prove why, let's examine the number of hams on each day first. So the only way to get a ham choice is if we had a cheese before, because if you have a ham on the day before, we can't have another ham, as that would break the consecutive rule. We can write this as the number of hams on a day is equal to the number of cheeses the day before. And I'm going to formalize this by making a function called h of n. So the number of hams on the nth day is the number of cheeses on the day before, or n minus 1. Let's test if this works. So h of day 3, so h of 3 is equal to c of 2. So how many cheeses do we have on day 2? We had 2 cheeses on day 2, and this should be equal to the number of hams we have on day 3, which is 1, 2. So this works. Now let's examine the number of cheeses we have on each day. A cheese option can be made from either a ham option or another cheese option, because it doesn't have the restriction of not being consecutive. So we can write this as the number of cheeses on a certain day is equal to the number of hams on the day before plus the number of cheeses on the day before. And if I formalize this, c of n, so the number of cheeses on the nth day, is equal to the number of hams on the nth day minus 1 plus the number of cheeses on the nth day minus 1. So let's test this for day 3 again. So c of 3 should be h of 2 plus c of 2. So c of 2 is 1, 2, and h of 2 is just 1, so that's 3 altogether. And that should be the number of cheeses there are on day 3, which is 1, 2, 3. So that works. Now we need to combine these 2 equations we've made here. So first I'm going to define a new function called t of n, and this is really similar to what we did at the beginning. So t of n just gives the total number of plants on the nth day. And this is defined as being the number of hams on the nth day plus the number of cheeses on the nth day. So if we go back to that slide, t of 2 will be the number of cheeses, which is 2, plus the number of hams, which is 1, which is 3, as we calculated here. And t of 3 will be 5, and t of 4 will be 8. Which is just the sum of these c's and h's. And we already know that the number of hams is the number of cheeses the day before, and the number of cheeses is the number of hams the day before plus the number of cheeses the day before. And we notice that in this definition, this h plus c is quite similar to our total function just the day before, as we're using n minus 1. So we can redefine c of n as being the total of the previous day. And this makes sense because let's say we want to find the number of cheeses on day 3. That'll be equal to the total plans on day 2, which is 1, 2, 3. So we've got our two definitions for h of n and c of n here. Now I'm going to substitute these two back into the first total definition. So t of n is equal to h of n plus c of n. Since h of n is c of n minus 1, I have that here. And since c of n is t of n minus 1, I have that here. So that means t of n is equal to c of n minus 1 plus t of n minus 1. But c of n minus 1, I can redefine as being t of n minus 2. This is because we can substitute n minus 1 back into this definition here. And that will give us t of n minus 1 minus 1. And that's how we get our t of n minus 2. And now we can put this t of n minus 2 in place of the c of n minus 1 here to get a final definition of t of n equals t of n minus 1 plus t of n minus 2. And this is just a formal way of saying the total plans on the nth day is the sum of the total plans on the 2 days before it. And that is the same assertion we made over here. So that's the explanation on why this is a Fibonacci sequence. Now the question is asking us to find the total plans on day 11. So we need to calculate t of 11. To do this, we already derived our formula here. So we can just make a list of values of n and t of n. And this just follows a very simple Fibonacci sequence. And for t of 11, we get a final value of 233. So there are 233 plans for day 11.